Hello and welcome to today's webinar on Agentic AI in Industrial Settings, brought to you by Kongsberg Digital. From the early days of computer vision to today's autonomous coordinated agent systems, the story of AI in industry has been one of steady evolution, and we're now at a pivotal moment. Today, we will explore ideas from their new book, which brings together leading thinkers and practitioners on how AI agents are transforming industrial work. In keeping with this theme, we will also explore recent findings from a market research study on agentic AI in heavy asset industries. I'm Jade Dupree, your host and coordinator, and I'm delighted to be joined by Oyston, Krishnan, Kushik, and Ram, who will share insights from their chapters and experiences, and Bernard, who will share their survey findings. Together, we'll explore how agentic AI is transforming industrial work, governance, and the journey towards safe scaling. Let's get started. Our first theme takes us on a journey from the early days of AI, image recognition, to the heady heights we're reaching now, which is agency and automation. I'd like to begin by asking Krishnan to set the scene for us and walk us briefly through what agentic AI is.
Thank you, Jay. This is really an excellent question. And I would say high level, if you look at automation and image recognition, which you can take as starting points, they were, I would say, reactive. There's a situation, there's an action. You can think about that as you press a button, you close your garage door, or you set the thermometer to a certain set point. That's, I would say, the earliest form of automation. Now you jump ahead and you get more complicated things happening, such as image recognition, where you can take an image and then there's a lot of math behind this, and then it can tell you what's a dog, what's a cat, and more interesting things as well from an industrial setting. Now you jump now to I would say the large language models, and that's what everyone is talking about, ChatGPT and all those kind of models. That's another jump in evolution, and that is introducing, I would say, reasoning to a certain extent. It's not real reasoning, but it looks like reasoning. But it takes certain types of input, certain types of data, and you can have a conversation. Now, if you take all of those steps now, you put them together, you can start saying, well, I can interact with one of these models, and in a passive fashion, I can ask a question, I can get an answer. That's reactive. Now, you can also start saying, well, I'm going to give certain sets of instructions, which is saying, keep my house comfortable, keep the process under control. And then small programs, small agents start working, and they start working together. And you don't know exactly what they're doing because you haven't told them explicitly, but they're doing all the right things. So they'll observe, they'll see what is your temperature, when do you come home. It's like the Nest thermostat. And it will start adjusting the temperature. So that's really what agentic AI is. It's a collection of agents which work in a somewhat autonomous fashion. You give them, I would say, somewhat simple instructions, and then they actually run the things for you. So it's actually very, very exciting that we're at this stage of technology today.
Now, reflecting on the journey that AI has been on, how did we progress from basic image recognition to agentic AI, and what were the key breakthroughs, do you think?
So there have been a couple of breakthroughs. One is obviously the evolution of technology. And you can look at that and say, well, how did you get from image recognition? Why is image recognition working so well? It's because you had the compute power. It became available. 10, 20 years ago, nobody really was talking about AI, except maybe academicians in universities. But AI was actually thought of and conceived maybe in the 50s, maybe even earlier than that, depending on how far back you go and what definition to use. But it just wasn't possible to do the kind of things that we're doing today because we didn't have the compute power. We couldn't get the data from A to B, and then we couldn't store the data. And today, that's one thing which is completely different. And then if you look at image recognition in particular, I'm glad you're using that as an example. Image recognition uses a picture, which is basically, well, It's like a matrix, right, in mathematical terms. And computer architecture started looking at those things from gaming perspective. So if you want to render images, you need to use certain hardware. And it turns out that when you start going into certain branches of AI, you need exactly the same kind of hardware. So that hardware was being developed for games, and now it was becoming very, very applicable to AI, to large language models in particular. And then that explosion really started happening in terms of what you can do and how you can do that. And that's how that evolution to agentic AI happened. So you went from images to large language models, the chat GPTs, and from there it's step on, step on, step on. And we don't know what's going to be coming out tomorrow, who's cracked another interesting use case and used interesting pieces. But that's sort of what's the enabling infrastructure that's made it happen.
And in your view, why is agency, the ability for AI to act autonomously, such an important next step for industry?
I think you can look at that from multiple lenses. One, if you are giving instructions and you have to give very, very detailed instructions to an AI, it's going to take you a lot of time, and you're going to get limited output. So it's very, very similar to taking somebody fresh out of school, and then you have to be very, very explicit about, well, you need to do this, you need to do that. Now, as with young people or people straight out of school, at some point they start learning, and then you don't need to give them all the explicit instructions anymore. You can say, well, I need you to do this design for me. I need you to design a plan. They'll come back with some questions, and then they'll go and design it for you. And that's really what's being seen as a force multiplier. So you go from programming explicitly what you want to giving, I would say, relatively simple instructions, and then the AI is no longer a simple automated agent on steroids, but a real intelligent agent which can work autonomously, and you can actually start having the discussions and I would say sparring, so to speak, with this partner to actually get to your point. So you will have more time for yourself to think about other things that are very important, and you can leave some of the tasks to the agentic AI worker or the program to figure out.
And one final question for you. Some people argue that full autonomy in industrial systems is quite risky. How do you see the balance between automation and human oversight evolving?
And I think this is going to be a back and forth. I think when you start new technology, you always have concerns, and you need to put the right guardrails in. And this is no different than if you look at the evolution in cars, for example. Initially, way back when you had a car, there's no such thing as cruise control, right? You have to make sure that you stay at your speed, and then there was something called cruise control which came, and that cruise control at that point was, I would say, the most primitive, because it would just set that speed. It's not going to sense if the remainder of traffic is going at that speed, if it's going faster, is it going slower, no such thing. It's just going at that speed. So as a human, you would sit there and you would intervene when the environment and the speed that the car is going were not consistent. And then you got something called adaptive cruise control. And I think that came about 10 years ago. And I was very excited when my car had that, because then I could just set the speed and I could actually just sit back, because it would brake, it would accelerate as necessary. But I would still intervene if I thought, okay, this is not making any sense. And then you had lane assist to tell you if you're starting to swerve, get out of the lanes. And then from there, you went to autonomous. So it's step by step by step. And you can say the same thing for industry. Or you let your agent do simple tasks, and you'll see what does it do. And most likely, you'll keep the safety critical ones on a different system till you're confident and you understand the bounds of what's really going to happen, the unwanted behavior, etc. So that what you call closed loop will be there for a long, long while, till you're completely comfortable that, yeah, actually do it in an open loop fashion. meaning you can take the human out altogether, and then the system will do whatever is necessary. But from a design perspective, from a human-centric design perspective, you'll have to make sure you have the guardrails, the feedback that things can be corrected, and look at what's called edge cases, where things that are not anticipated and something may go wrong, that you actually look at that, you design for that, or you have the appropriate intervention when things are not in the playbook. So you're not going to get to the fully autonomous state overnight, and you're definitely not going to try to bypass the human. You're going to work with the humans who are using it and make it a force multiplier for them.
Thank you, Krishnan. It's clear that we're moving beyond point solutions to systems that can reason, coordinate, and act. This sets the stage for how humans will engage with these agents and means that we're going to hear from Ram next. The book discusses how knowledge workers and operators are becoming managers of agents, which is a fascinating change. And Ram can help us explore what that means in practice. What does that shift look like in practical day-to-day industrial work, Ram?
Thanks, Jade. Let's take the example of an asset reliability engineer who's working in an industrial plant. So what he would do is he'd normally spend his day looking at streams of data from turbines, compressors, pipelines, and just crunch through it manually. And then he'd put the data in spreadsheets and do some analysis. And based on his experience, he'll make decisions. But what he could do now instead with AI technology is he can actually have a swarm of agents that actually will do various tasks. You can have a data agent that would gather all the data, put it in a database, have it readily available. You can have an analysis agent that will analyze the data and identify trends and also potential problems. Then you could have something like on predictive maintenance, for example, that looks at the historical performance of various units and the actual data predict when something may fail. And finally, in the area of safety, you can look for safety. So those are some of the different things he can do. So now instead of doing all this work manually, it's orchestrated by a bunch of agents. But at the end of the day, he will actually look through the information provided and help make decisions, right? If we decide we might need to order a new part, he'll look at the data and say, yes, that looks reasonable. I'll order a new part. Or you can say, no, we need to do more analysis. Can you look at this, look at this factor you haven't considered and do that? So the human, in most industrial scenarios, the human's still going to be very critical to making any important decisions.
So what new skills or mindsets will workers need in order to collaborate effectively with AI agents?
Well, I think the thing, everyone doesn't like change, right? You're used to doing things in a certain way, and everyone doesn't like change. But if you say, we're going to make changes that will make your life a lot easier, and you deliver on that promise, then no one can complain about that. So that's why it's really important that whatever system you develop, the expert is involved in the design of the system. Obviously, he's not going to design it himself. He'll get a team of AI data scientists and AI engineers coming and helping him. But it's really important that the expert work with the team to design the software, design the solution, and design, test it. And at the end of the day, he gets a product which he knows will genuinely be useful. So day to day, you come in, you have a dashboard that has all the main key metrics. You get an email or a text if there's something that's important that you need attention. So it just makes his life easier, and he can spend more time on high value tasks, not just playing on spreadsheets, looking at data, which, to be honest, machines are much better at looking at vast quantities of information, looking at trends, so he can do what's best for him. And so that's really what's really important, is to have a system that genuinely makes their life easier, and then everyone will adopt it. And with the technology that's available today, there's no reason that can't be achieved.
Understood. So could you share an example where human agent collaboration has led to better outcomes than either could have achieved alone?
Yes, one big example is in the oil and gas industry. The management of platforms is now using digital twins and AI agents. So the digital twin provides you all the data from all the different equipment on the platform, and the AI agents will help you analyze all of it. So basically, the agents would do things like, first of all, they'd gather all the data, put in a database. Then they would start doing some analysis of the data, looking at all the various things, and then it can then start giving what actions, saying these are the actions that should be done based on that analysis. And then there could be another layer we actually say, let's execute, let's make these, let's order the equipment and all that. But for the last two phases, the humans would be involved, right? They see that does what it recommends to do. Does that make sense? It's saying, let's change these valves and do this thing. So they can check, yes, that makes sense. No, it doesn't. And say, let's order this replacement pump because it may due to fail very soon. So then the human would then be involved in that aspect of it. And that's really where we're headed to. I mean, in the past, we had what I would say is like, we just have a chatbot and you have a simple, you ask it every single task. The human goes to the chatbot, show me this, show me this. Now with the agents, they can do a lot of that legwork for you, but ultimately the human makes the decision. Now in complex systems like oil rigs and other industrial facilities, fully autonomous, it's going to be a long time before we have that, simply because of safety issues. Because if the AI, if there's a mistake made, it could potentially have catastrophic effects, like in things like aviation, oil and gas platforms, other platforms. So the human's going to be involved in the loop for critical things. For other for example, if you're creating a marketing system, those are now almost fully automated, right? Someone sends you an email and then you qualify leads and all that. That can be almost done and fully automated because it's not really high impact. So, I mean, but as time goes on, we will get more and more autonomous, and only the critical decisions maybe will be left to humans.
Thank you so much. So what I'm hearing is that collaboration isn't just about efficiency, it's about building scalable intelligence where people and AI together achieve more than either could alone. Our third theme is one that can't be ignored, actually engineering secure and explainable agentic systems. As these agents act with more autonomy, risks increase, and so does the need for trust, resilience, and oversight. Upstream content studio producer Jack Dean caught up with Kushik earlier on this matter.
Thank you, Jade. Security, resilience, and explainability are recurring themes. What are the biggest risks unique to agentic AI in industrial settings?
In industrial settings, the margin for error is extremely small. A wrong recommendation or an unchecked action could mean downtime worth millions, safety hazards, or even environmental damage. That's why the biggest risk with agentic AI is not simply technical failure, it's confusing support with autonomy. For decades, automation worked because it was predictable. Controllers and rule-based systems executed within a fixed boundary. But with agentic AI, we now have systems that interpret context, run scenarios, and recommend actions on top of it. That flexibility is powerful, but if not bounded, it creates risks. Cascading errors, misaligned optimizations, or agents acting outside the scope. The safe way forward is, I think, a bit clear when we say AI should accelerate human judgment, not holistically replacing it. In practice, that means agents in a cognitwin or an industrial work surface environment surface anomalies, simulate outcomes, and highlight risks. But the authority to act always rests with the human operator. Globally, we see the same lesson. When AI oversteps into unchecked decision making, trust automatically collapses. In industry, trust and safety are everything.
Thank you. And how do you design systems that not only work but are trusted by engineers, operators, and regulators?
Trust is built when people know that the system is a teammate, not a substitute. For engineers and operators, this means they remain firmly in control, with AI serving as a decision support. The agent can analyze sensor data, compare with historical patterns, and simulate likely outcomes, but the human chooses the final course of action. In our product, we emphasize human in the loop design. Every recommendation comes with a context, why the agent flagged it, what scenarios it tested, and what the trade-offs were. Operators don't just see a prescription, they see reasoning they can validate. For regulators and safety bodies, trust comes from auditability and transparency. We maintain decision logs, validation protocols, and alignment with industry standards. This ensures AI outputs can be traced, inspected, and certified just like any physical equipment. So, the design philosophy is pretty simple: empower humans with better intelligence and not to replace them or displace them. When engineers see AI as a trusted advisor rather than a replacement, adoption automatically accelerates and safety is preserved.
Explainability is often at odds with performance. What strategies or tools are emerging to bridge that gap?
When people say explainability is at odds with performance, they usually mean that the most accurate models, the ones that optimize best, are also the least interpretable. In other words, you get raw performance at the cost of transparency. But in industry, particularly in safety critical environments, explainability isn't optional. Operators and regulators need to see why an agent made a recommendation before they will act on it. The strategies we see emerging are about bridging the gap rather than choosing one or the other. First, layer explainability. Different stakeholders get the level of insight they need. Operators sees a clear, actionable explanation in their own language. Engineers can drill into simulations or variables, or data scientists can go all the way down to model intervals. Second, surrogate modeling. A simple, interpretable model runs alongside a complex one to provide human-readable explanations. This way, you can get high performance without leaving humans in the dark. Third, simulation-driven explainability. In platforms like Industrial Work Surface, the twin itself becomes the explanation. Instead of showing the math, the system can replay scenarios, highlight hotspots, and simulate outcomes so users can see the logic unfold. And finally, audit trails and model cards are becoming industry standards. Documenting what data was used, how decisions were made, and under what conditions plays a huge role. So the real shift is this: explainability is no longer viewed as a trade-off with performance. It's becoming a design requirement. The future isn't choosing between the two. It's engineering both into your system.
And lastly, in all we do, governance is crucial. Who should be responsible for setting and enforcing the rules of behavior for AI agents in industry?
Governance is about defining and enforcing the boundaries within which AI operates. And in industrial AI, boundaries are everything. The authority to act must remain with humans. The AI just provides recommendations, not final commands. Responsibility sits across various different layers. Regulators and standard bodies define basically the minimum safety frameworks. Companies and operators adopt those rules to their specific plants, setting policies on what agents can see, what recommendations can they make, and why human approval is required. And finally, technology providers like us enforce these rules in the design system itself, through role-based access, audit trails, fail-safe mechanisms, continuous monitoring, and also having a thorough compliance rule-based system. Globally, governance is moving more from being seen as a burden to being a competitive advantage. Companies that can prove their AI is explainable, auditable, human control will be trusted mostly by regulators, insurers, and the workforce. So the guiding principle is agents can accelerate, but humans decide. Governance ensures that balance is never broken in this case.
Thank you for your time. Back to you, Jade.
Excellent points from Kushik and Jack. It seems the challenge isn't only technical, but also organizational and regulatory. It's about aligning stakeholders on what safe and explainable really means. Our next theme introduces a compelling concept, the industrial work surface. From digital twin to executing work processes, this is where theory meets practice, embedding agents directly into how work gets done. Oyston, this is your area of expertise. Many organizations already use digital twins. So how do agentic AI systems impact this concept?
Yeah, thanks, Jade. So I think we've already seen that agentic systems will have a profound impact on the whole spectrum of challenges that we tackle in the digital twin space. It even begins at inception. It begins at how you create digital twins, because we see that all the work that needs to go into data integrations, to data modeling, to quality issues, into semantics and ontology building, for example, can be greatly helped by having then a swarm of agents, help you to figure out the patterns and identify the quality issues that you have in your data. And all of this contributes to the overall quality of the digital twins that are being built. And of course, second, at the other end of the spectrum, it will profoundly change the experience. What do you expect from a system that you interact with as a user? And to give you a truly multimodal experience, right? It changes how we can expect to interact with the system. Can we use our voice? Can we use the visual surroundings to help the system to guide us through what we're supposed to do? And can the system produce other things than text for us? Can it produce the images, the graphics, or can it simply use voice in an environment where it's not suitable for you to, for example, be reading or focusing on a screen while you're doing critical work? And of course, all of this impact, it ultimately leads to us being able to accelerate the adoption of this technology, because it makes it compelling to use. And with all the large quantity of data we have and all the sets of tools and everything we have at our disposal to access this, it's still a matter of making it possible for us to adopt all of this technology at once. And if we're ultimately able to just express our intention to a system that then has agency enough to select and combine these tools on our behalf, then we will see this truly change how people work.
So what does the industrial work surface mean in practice then? Could you give us a concrete example?
Yeah, so the industrial work surface is all about end-to-end work, right? Covering the end-to-end of this. And it's all about kind of providing structure and closing the loop so that what you're doing is connected. And then leveraging these connections and the structure to provide the patterns and, let's call it, the data that you need to optimize, whether it's optimizing from a production perspective or optimizing how you actually execute your work. And end-to-end work is not about kind of clicking from screen to screen to screen and then going back to the start, right? It's about making sure that the data and the processes and the actions that we execute in the system have connections and that we continue to build these patterns to improve. And one specific example that's been close to us is governing the overall risk and working with risk management for an asset, right? It starts even at the planning stage, where you can imagine that identifying which kinds of risk are key to keeping your people safe, keeping your asset operating smoothly, can be greatly assisted by also leveraging agents to help you build structure around this data, so that instead of having complex drawings that people have to interpret visually, we express it in rules and structured language so that the computers or the systems are able to use this information. Now, feeding that forward into, for example, how you set up your actual day-to-day monitoring and operations of the asset, you can use that structured data to help you plan what equipment is critical in function to avoid unscheduled downtime or incidents. And of course, how to integrate this into your control systems, how to monitor all of the health of this critical equipment. Now, this kind of gives you an overall view of what's important for the operations of your asset. And then you step into managing this on a day-to-day basis, so that you look at, for example, the current state of important equipment. You look at the temperature, the vibrations, the overall health. And then this indicates to you whether or not you're building up risk or whether or not you're operating with large margins to where you need to be. And of course, this feeds forward into another process, which is to identify, out of all of the options you have today for how to maintain your critical equipment, where should you begin? What's the most important one? What's methods that you can use in order to plan and schedule all of the maintenance and inspections that you need to do on your asset, to do this in an optimal way? And then ultimately, right, if you do your planning and scheduling based on risk priorities and the state and the health of the asset, and you provide all of this data and all of this structure to all the people that will execute and all the systems that will execute the maintenance and inspections on your behalf, then you're starting to get like a red thread all the way from when you created and planned how you're supposed to operate your asset through the actual state of operations into how you execute the work that is needed to run and maintain. And by doing it in this structured way, you can then capture all the dependencies, all the patterns, and leverage that, for example, using both AI and our own kind of analytics to feed this back into the beginning of the process and kind of establishing a forward-looking improvement cycle on everything that we do.
So one final question for you, if you don't mind. How do we ensure reliability when AI agents are embedded in critical decision-making loops alongside human experts?
Yeah, so first, it has some elements of generic technology adoption, right, that we need to address. So when we're adopting technology, it's always important to kind of follow engineering principles that allow us to introduce the technology in the right way. So it's a combination of providing, for example, full transparency in some areas and providing verifiable, trustable technology in other areas and combining this together in a way that people understand. So just as an example of the difference between kind of trust and verifiability, right? Then if you open, say, Excel and you plot 2 + 2 into one of those cells, right? You don't expect that system to explain that behavior to you because it's well established, it's well known, and it's governed with technology that we adopted, decades ago, so that we can establish trust in that part works. But if you have someone in an organization, for example, and you ask them, can you show me out of all of these numbers what we should be focusing on? And they provide you an answer, then the typical follow-up would be, well, can you rationalize why you select this specific area to focus on, for example? And we'll see the same with AI adoption as well, because in some areas, when it comes to data access, when it comes to security, and when it comes to how it's being embedded into critical systems, we need full trust and verifiability, right? So that there's no escaping that. But then when it comes to the different scenarios where we can apply it in a more organic manner, then it's more about making sure that we have full transparency into how agents work, which tools have they used, what data did the tools produce, how has it combined those data together, and ultimately is what it's presenting back to you transformed by AI, or is it simply leading your attention to something that is a kind of a verifiable fact in the system. And then I think secondly, it's all about context, because if we want to play to the strength of AI, we know that if you give it no context and ask it to come up with facts, then that's one of the things that generative AI is capable of. And of course, that's not the property we're interested in at all in industry. What we're interested in is the AI's capability to transform from a representation or a set of facts over to a different representation of those facts, often finding the patterns and the combinations that are already in there and ultimately presenting them back to you in a way that you hadn't seen yet, so that you're not really generating or inventing anything, right? You're using it to its strength. And that's what we're seeing with when we apply it to translate between different representations. So again, translating between what you type into the chat and actions that the system can take towards a database or towards calculations, for example. That's a translation. It's not a generation of instructions per se. And the same thing goes back to you when it's able to, for example, translate representations, languages, and so on. So we need to leverage these things. And of course, to get all of that context, it means that in an industrial setting, the AI often needs to be more integrated into how this work surface works than just being kind of an add-on at the end, because it needs to be able to both find and present where the actual facts in the system are, so that you as a user will never be misled or kind of miss what you're looking for.
Understood. Thank you very much. So we're seeing digital twins evolving into execution environments where human expertise and AI agents collaborate in real time. Now let's hand over to Bernard at Forrester Consulting, who sat down with Jack Dean to discuss their survey.
Kongsberg Digital commissioned Forrester Consulting to explore the state of agentic AI in asset-intensive industries. A survey was conducted with 454 decision makers for AI agents and the optimization of assets in operation at organizations in asset-intensive industries to test this hypothesis. Let's dive in. Could you elaborate on the findings of the survey?
Of course, with pleasure. Thank you very much. Let me quickly share my screen. And I'd like to start with a couple metadata. They are important. As you already said, Jack, we surveyed 454 senior decision makers. Now, who are these senior decision makers? Spread across the globe, as you can see from geography, APAC, Europe, Middle East, North America. We have a size limit, so at least 500 million recurring US dollar revenue. That's important. Industries covered: chemicals, energy, manufacturing and materials, oil and gas, and utilities more broadly. And we also put a threshold regarding maturity of technology adoption in there. As you can read, companies must at least be piloting AI agents and either a digital industrial platform or digital twin in productive use. Departments we were interested in to survey the senior decision makers from: data department is existing, innovation department is existing, of course, corporate or a business line, IT, and maintenance or operations department. So title, senior manager or above. And of course, regarding responsibility, must at least be influencing decisions on the topic we were covering, like the digitalization of large industrial assets, or AI adoption, or digital industrial platform adoption, or digital twin, or ideally all of it. And here are the insights. Quite interesting what we learned. One thing, as you can read, AI drives transformation. However, agentic adoption or adoption of AI agents lag behind. And there are a couple of reasons why, but let's first dive into the data from the top. So critical priorities only, and the study itself also provides the data and the priorities on all these aspects, and gives its percentage values for priorities that are less than critical. But critical priorities, out of these surveyed respondents, 56% said accelerating digital transformation with AI is critically important for us. 54% said strengthening cybersecurity for AI systems is critically important for us. 53% said investing in AI training and upskilling is very important. And as you can read further down, data governance for AI readiness, scaling AI adoption, and only then respondents said, yeah, deploying AI agents to support frontline workers is important for us, or automating internal workflows with AI agents is important for us. Now, there are at least two reasons for this spread of responses. Number one, these decision makers we surveyed pretty well understood that it doesn't make too much sense to rush at AI agentic adoption before you have prepared your ecosystem, your groundworks, your capabilities. And these capabilities are digital transformation, provide cybersecurity, upskilling, reskilling, training people, the right governance you need. So that's the positive explanation for these results. The more negative is that decision makers are just not mature regarding AI agentic adoption because they haven't decided upon the right vendors for them up until now, or they didn't get the internal approvals from maybe procurement, maybe from IT. Again, this is the more negative reading of these data, but quite interesting. So AI is front and center, but adoption of agents, not necessarily. We also asked those that adopted AI agents already in these asset-intensive industries, what are these agents doing? And we were quite surprised to see that 68% said, my organization is already using AI agents, but for very specific tasks. This is not part of the surprise, but the surprise is on the right-hand side. 39% saying we are using already multi-agentic AI systems to manage interconnected workflows. In other industries meaning financial service providers, healthcare, of course, government, public administration, hardly anybody is using multi-agentic AI systems yet. And initially we thought, maybe these responses are biased. That cannot be true. But as we moved through the remaining questions, and I'm going to share them with you, you will see that actually there are reasons why in asset-intensive industries, adoption of multi-agent AI systems that manage more complex processes, not limited to a specific task, has such high adoption levels. What we also learned that readiness for agentic AI is truly split. The long-term strategy and the strategic commitment is kind of homogeneous, but readiness is quite heterogeneous. Starting from the left top, only 45% of respondents said we are confident in our ability right now, as a snapshot in time, to govern and oversee autonomous AI systems. 54% said our organization has the internal expertise to effectively deploy AI agents. So almost 50% saying, we don't have the internal expertise yet. So they all see there is room for improvement because as you look to the right-hand side and the long-term commitment, we only picked the responses that strongly agreed to our key statement or assumption, like the one from the top. Our organization has a clear long-term strategy or a target state for adopting AI agents. More than 80% agreed to that. That's amazing. On number two, we have a clear roadmap for scaling AI agent use cases across the organization. Almost 80% agreed to that. Agentic AI is seen as a strategic enabler of operational transformation. So people want to get there, but know that government data oversight issues are still predominating, so they have to work on these. But also, making the organization appropriately upskilled to deploy AI agents. Quite interesting insight. So coming from that notion of AI agents are becoming strategic players and are part of the long-term AI adoption strategy, we also wanted to understand from these decision makers, what are the primary strategic objectives for AI agents, not AI more broadly, but AI agents. 63% responded, we want to use AI agents to automate more. So we want to transform existing operational models to automate more. We want to enable autonomous decision makers, or at least semi-autonomous decision making through agents. We want to improve resilience and adaptability in operations for whatever that's coming from the outside or from inside. Supporting sustainability and decarbonization goals. 50% responded that. That was a surprise to us because more broadly, when we do our Forrester-specific surveys around AI adoption and AI agentic adoption, across the board, sustainability and decarbonization goals are ranking really low. In asset-intensive industries, this seems to be different for the good. I really appreciate that, but it's quite interesting to see that result. And of course, accelerated digital transformation, that's always among the top priorities. Here is priority number 5. Not too much of a surprise, but specifically the sustainability one, at least to us, was a surprise. We also asked now, what are the limiting factors? What are the prerequisites? What are the success factors for successful AI agentic deployment? And here are the four most critical ones: explainability and transparency of AI decisions, not only in order to turn it into a trustworthy technology, but also make people trust this technology and feel confident about leveraging AI agents. Very important. 51% responded, human in the loop or override mechanisms are truly important to adopt AI agents in our industry. 46% argued cybersecurity and other security protocols are very important to broadly adopt AI agents. And 43% said fail-safe fallback mechanisms are very important for us to broadly adopt AI agents. We also asked about typical struggles we are seeing elsewhere when adopting AI agents, and we split them by the adoption maturity of the organizations surveyed. And as you can tell from the 4 colored categories, these are representing the maturity stages from the dark green to the light blue. Dark green means, as you can see from the top, we are in our initial implementation stage. So we finished piloting. Now we are in initial implementation of singular individual AI agents. Light green indicating, at least one asset or at one site we have productively implemented AI agents. Dark blue saying at multiple sites or throughout multiple assets we've implemented AI agents. Light blue, we implemented and used company-wide. Now, at the beginning, not too much of a surprise, poor clarity on ownership and accountability accounts for the highest degree of challenges, 50%. And this goes down as companies mature because they learn they need to be clear on ownership of data, ownership of agents, also ownership of agentic outcomes and accountability. And our accountability doesn't go away. It's similar to your human employees. Ultimately, the supervisor is accountable for what human employees are doing. And the same is true for AI agents. The supervisors, the accountable people, usually managerial roles, are accountable, not responsible, but accountable for what AI agents do. As companies mature regarding AI agentic adoption, they learn what it takes to own outcomes and be accountable. That's why the number is going down. Data quality issue. At the beginning, that doesn't matter too much. Why? Because usually agentic adoption, as you could tell from one of the previous questions, is a thing which is very niche. So you build for a specific task and all the surrounding data are not interesting so much. Now, as you implement AI agents more broadly, across sites, cross assets, data quality issues become prominent, challenging, which is why the highest maturity, the company-wide adoption, is starting to learn how to solve them, which is why the figure is going down to 49% from the initial 57%. Lack of interoperability between AI tools and existing platforms doesn't matter so much when you are in a beginner state, when you implement these individual isolated AI agents. But as you adopt cross-company, cross-sites, cross-assets, this is becoming a true challenge, which is why we see the figure going up to 46%. Lack of internal AI governance frameworks. At the beginning, doesn't matter so much. But as you move across company regarding adoption, this is becoming very, very important. Trust and security remain top concerns, not too much surprising. We summarize the result on the left-hand side. Organization side explainability, adaptability, but also security and cybersecurity as top concerns. But also the maturity level of AI agents from a technological point of view are also adoption barriers. One question we asked very specifically, how established are your organization's capability to scale agentic AI across the following areas? And that's quite interesting to see. And the results we are showing here are for those responses where people believe they either have no capability in place or very early, rather immature stage capability. Number one, training employees to work with AI agents. So there is a lot of room for improvement. Establishing governance, we already covered that. Managing change and employee engagement, not surprising, but they acknowledge that this is an area where they have to improve. But also monitoring, continuously monitoring and evaluating the performance of AI agents. So scaling agentic AI requires training, upskilling, the right governance, and to prepare the workforce for that regarding not only engaging with these agents, but also being confident about the results of what these agents are doing. Quite important. We asked a couple questions about the future of agentic adoption and also what these decision makers believe that will look like. And as you can see, 71% believe that AI agents will play a very important and meaningful role in shaping future organizational strategy. And we gave them a couple exemplary responses. From the top, we believe that AI agents will be embedded in key processes, key workflows. They will automate very complex tasks. They will improve decision-making. They will enhance productivity. 38% of the respondents agreed to that. Going down a bit, AI agents will become an integral part to my organization's core operations. Yes, they will fundamentally transform the operating model. They will help working side by side with humans, but they won't get too much or too significantly into autonomous decision making, as the above response suggests. And 33% agreed to that statement, whereas only 17% agreed to the statement further down, saying AI agents will support specific functions. Yeah, they will help with things like maintenance, energy optimization, but pretty specific to specific tasks, but not so broadly covering the whole organization. The 11% said, yeah, they will remain experimental or limited to some pilot projects. So we don't trust in the technology and we don't trust in the technological evolution. So almost 3/4 of the respondents believe that AI agents will play a transformational and meaningful role in navigating the future. Another one regarding transformation, quite important here, is about the benefits these organizations expect. And these organizations are the ones that sit in industrial conglomerate. So we asked them about, do they see benefits within the next 12 months, which is short term? And again, almost 75% see sustainability and emission reduction as important contributing elements from the agentic world. Improving safety and risk mitigation, also quite high on the agenda. Accelerated time to value for digital transformation initiatives, still quite high on the agenda. attracting and engaging next generation talent is an interesting take in my opinion, because I see AI as a driver not only for engagement, but also to make a positive reputation for the company as an employer. It's quite an important aspect. Greater scalability and flexibility to adapt to changing business needs still high on the agenda. So this is what asset-intensive industry representatives are thinking about, what AI agents can do within the short term, the next 12 months, where sustainability is high at the agenda, but also greater scalability and flexibility. Quite important insights. And last but not least, they believe agents empower the future workforce and also the future workplace. And how? By enabling less experienced workers to make better decisions with AI, and specifically AI co-pilots. But also preserving knowledge. People are leaving the job, moving elsewhere within the organization, leaving the organization. They see AI as a great way to keep the knowledge, to capture the knowledge. Supporting faster onboarding and training for new employees. Absolutely, especially as it ingests all the mountains of data and knowledge and information and provides it to the employees, to the new hires, in a very digestible way. Increasing job satisfaction by automating repetitive or low-value tasks. And last but not least, supporting remote work models or hybrid work models. And these 5 insights are coming from a plethora of questions which I didn't have the time to go through, but this is also part of this complete survey. So I guess the impact on the future workforce is equally important, as is the asset-intensive industry-specific benefits coming from AI. And with that, I'd like to thank you very much for chiming in.
Excellent. And just before you go, what key takeaways do you want the audience to leave with today?
Maybe 2, if I may. Number 1 is prepare yourself, as we could also see from the service respondents, especially the ones that are more mature. Break down your data silos, curate your data, label your data, make data accessible. Very often, accessibility of data is a power play. That must go away. That's very important. And number 2, having employees part of the journey and not just consume AI once it's somewhat finished, no matter if it's a pilot or a productive implementation, but including them from day one, because they are the subject matter expertise. Not only helps to create better AI adoption, also long-term, but also ensures that people are starting to trust the technology. The more you expose them to the technology, the more they trust it, but also they understand the limitations. It's about trust, it's about transparency. And I guess the variety of questions we asked and the responses we were getting are confirming this second of my takes or my views on AI adoption.
Thank you for your time. Back to you, Jade.
Thank you, Jack and Bernard. Unfortunately, that is all we have time for today, but I'd like to thank you all for your inspiring perspectives, and thank you to our audience for joining us today. If there's one clear takeaway from this discussion, it's that agentic AI is not about replacing people, but about creating new forms of partnership between humans and intelligent systems. The future of industrial work will be safer, more scalable, and more impactful when we get this relationship right. We encourage you to read the book, continue the conversation, and think about how these ideas can shape your own organizations. Before you leave, please don't forget to download the handouts that Kongsberg Digital have provided around your screen. I'm Jade Dupree, and it's been a pleasure hosting this session. Until next time, stay curious and stay innovative.